Folks, let's get right to work. We're here to talk about passwords. And the reason I think that this topic is still important is because there's a lot of changes in the world of passwords just in the last couple of years. So the two main things we want to talk about is that the whole idea of what a good password policy changed has really changed based on how we see real attacks in the world. So I'm going to make a suggestion to completely modify what your password policy is for your applications, number one. And number two, how we store a password has really changed a lot in the last couple of years. There's only a small number of algorithms that's good to store passwords for your user's authentication verification. We'll go over those algorithms and methods as well. That's where we're going in this, we got about 25-minute, really brief webinar. Hopefully get right to the point and help you do your thing. Who am I? I'm Jim Manico, going to be your presenter today. I'm an author, speaker, and I'm primarily an educator. I teach developers how to write secure code. I got to tell you, I love doing it. It's a real joy to do what I do. I love to teach. I'm like my family, I'm fourth generation educator. Even back in my great grandfather in Sicily was a high school teacher. So part of my family lineage to talk, right? All right. Don't hack without legal written permission. Please vet your open source libraries, and keep them all up to date. So let's start with this. Passwords used by another user. Yeah, that's not the best error message. This is what we call a security oracle. And I don't mean Oracle, the database. I mean Oracle, the informant. This is an error message at the authentication layer that's giving information to the attacker that attacker shouldn't have. This lets me know that a password I'm trying is valid that can be used for some other user in the system. Other oracles I see, security oracles I see at login is when you leak if the username is good or not. Right? If you say like, oh, that user doesn't exist, or that password doesn't exist, you're leaking if the username is good or not. These are oracles at the error message level, so be careful. Be generic in your error messages. The username password combination didn't work, end of story. But let's get to work now. Now, the first big rule when it comes to password policy that I think is important is don't limit the password strength. We want to really use we want to make available to the user any printable character, end of story. And why is that? Because if you're trying to limit password characters to stop injection, like SQL injection, like if you're blocking less than or greater than sign to stop XSS, or trying to block the single quote to stop SQL injection, these are paths doomed to failure. A lot of banks used to do this. And I ask why. They're like, well, we get our systems right from security point of view. So the third-party software we depend on. So there's a lot of reasons why folks make these mistakes. But if you want to stop SQL injection, use the right defense. That's query parameterization, not validation or character limitation. And also, if you're going to validate, at the very least, you have to limit the password size. Like back in the day, in the Python world, the framework Django, they used a good algorithm in that era of time, but there's no size limit. So I could try to log into Django, any random account, any end of non-existing account, try a giant password, and I'll shut the server down. So limit the password size. I think that should be at least 64 characters for your max for passwords. So let's look at this. So now I have my own ideas, but I don't want to just let my ideas drive. I want to make sure we're looking at a good international, or at least a US-based standard that has done a lot of research to evaluate passwords. So you may not like NIST, right? NIST is the National Institute of Standards for the US, and you may not like that for whatever reason, but I still think the work they did is worth considering. So I don't care if you follow this standard. I care that you take modern password policy seriously. And a side note, if your authentication is only passwords, that's a big problem. My take is, I look at the ASVS standard, OWASP ASVS, and they're saying that the moment you, and I'm sorry, look also NIST 800, we're going to look at this standard in just a moment, NIST 800-63b. They're saying as soon as you have sensitive data in your app, you should be using multi-factor of some kind. And I agree with that. So the point is, if you have significant sensitive data on your users, privacy issues, GDPR type issues in your app, finance data, a government type of stuff, whatever you deem to be high risk, if you're not doing multi-factor, This is 2020, folks. That's negligence. And I don't mean to say that so harshly, but there's no excuse to not at least offer MFA to the users. Troy Hunt disputed this a few days ago, and I think it was compelling. He said, well, a lot of people who use MFA are people who use good passwords anyway, so maybe we have to reconsider this. So I agree with that, but I'm going to stick to the state of the art today for now. And also, you want to get your users to use a password manager, especially in a corporate environment, and that's not easy. You can't just throw a password manager at a user. They're sophisticated. There's a lot of details to get right to use them effectively. So you got to train your users like legit before you roll out a password manager to everybody. If you have family, like I rolled out a password manager to some of my family, and they each required a lot of questions to get some of the finer points. So this idea of throwing a password manager at a user and that's the end of the story, that's not a good way to do it. You got to train them. It's complex, especially for low-tech users. The biggest risk change that we've seen in the world of passwords is this concept of credential stuffing. It's not always dealt with well. Now, as you know, there's been many breaches in the world in the last couple of decades, and several of these breaches, like against LinkedIn, against RockU, against MySpace, and the whole Oath empire, these breaches stole data from their database in some way and leaked the username and password pair to the world. Researchers tell me there's upwards of even past 7 billion username password pairs in the wild that attackers know about. So, and what attackers do is, first of all, users, they reuse passwords all over the place. Even I do at times. So it's not easy not to. Use a good password manager will help, of course. But the point is that when a user tries to register a new username password with your system, check if that exists in public databases. If it does, block it, even if it's an otherwise valid password. The other thing is, if users trying to change their password, also check that username password combination against databases on these breaches. So that's critical. And a lot of authenticators, a lot of authentication systems don't do that. And that's a big gap. We see a lot of VPNs getting hit by stuffing. Username password pairs known in the public by attackers. They try them against multiple systems to breach your account. Also, use multi-factor. This makes this credential stuffing less of an issue. Still a problem, but less of an issue. And also avoid email addresses for a username. It's public data. The other big thing that I only agreed with until recently is also bot detection. A lot of the credential stuffing is done through automated attacks, and detecting bot activity will reduce the number of attempts that hit your system if you do it right. And that's usually a commercial product. You can't just build bot detection from scratch, in my opinion. That's why I'm hesitant to recommend it, but I give up. Bot detection helps. Also, here's the other thing. Suppose there's a major breach today. Suppose like Gmail got breached and all username passwords of Gmail were leaked to the public. That affects you right away. So whenever there's a major breach of a major service that you think is valid, scan for known username password pairs from that breach against your database and lock and force users to go through password reset if their username password was part of another breach. I have one customer who doesn't want to even do the compare. Whenever they see a breach, they look up those usernames and immediately force password reset on them to be a little bit more aggressive in that area. It's worth considering. Credential stuffing, you got to deal with it. Now, in other details of password policy, we're going to explore Special Publication 800-63b. These are the digital authentication guidelines for the United States. And you might be thinking, I don't want to follow United States standards, and you have all these European reactions, and I'm okay with that. I'm not telling you to follow the standard. What I'm saying is, let's look at what these folks have done. This is Jim Fenton, researcher, and let's look at what their work is and see which ones we want to consider for our system. So I'm not forcing a standard on you, but if you don't look at this research and consider it, I don't know what to say. Let's get into it, right? I mentioned this already. Don't limit characters of a password. We'll talk about more of that in a moment. So number two, here we go. The password, according to NIST 800-63b, should be 8 characters minimum and allow at least 64 character passwords, if not more. Amendment to this is, if you don't have multi-factor in place, first of all, negligence. And second, if you're not doing multi-factor, at least have a longer password policy of 16 characters. I'm part of the application security verification team at OWASP. This is our AppSec standard. And we believe we bumped this up to 12 to great controversy. So if you look at the ASVS standard, that will say 12 character minimum. I personally think 10 is a good number today. And NIST, from a mathematical point of view, says you can get away with 8 characters if you have multi-factor. Your mileage may vary. And like the bigger the size, the more customer service problems you'll have. But you know, there you go. The bigger is better when it comes to password size. 3, block context-specific passwords. Like the word password shouldn't be in a password. Like my company's Manicode, I shouldn't have the word Manicode or Manico in any of my passwords. Usually like 15 or 20 context words that would normally be okay in a typical policy should be blocked for your contextual service. That's right. 4, check against the list of common passwords. Daniel Miesler on GitHub has a repo called SecList with databases of all the most common passwords used in the world today based on breach data analysis. And I like those lists, they're fantastic. And Jim Fenton, who wrote NIST 800-63, says, block the top 50 to 150,000 passwords that would typically fit your policy, block those. Not just the top 150,000 passwords, but ones that would typically fit your policy and that are too common, block those. And like we mentioned earlier, we also want to check against the list of breached username password pairs from these breaches, 2 separate issues. Next, handle brute force in some way, throttle or lock the account, whatever you have to do. I prefer throttling as my defense, but handle brute force attempts in some way. Next, stop these nonsense password special character rules. Uppercase, lowercase, number, special character. It's not effective as a strategy. We need something better. Last, these security questions and hints, all of them need to go away because attackers can look them up in social media or guess very often. They're not effective security factors. A lot of the people from the world of KBA, knowledge-based authentication, who want to authenticate you based on knowledge, that's all about security questions. So I personally think knowledge-based authentication is bad. I'm not a big fan of it. It's relatively fragile. Next, no more mandatory password expiration for the sake of it. When folks expire passwords and force users to go through password expiration on a regular basis, they tend to do bad policy. They tend to just like bump a number by 1 or something that's predictable. So overall, don't reset a user's password unless there's a good reason to do so, like a breach or something like that. So yeah, we have questions in the Q&A feature. Hey, Jim, would you also recommend Troy Hunt's pawn password database to check for breached passwords? Not breached passwords, that's too big of a list, but breached username password pair together. Yeah, Troy Hunt's got a great service for that, and Google has one as well. And these are great services to tie into your authenticator. And I know that a lot of like governments use Troy's work now. So a ready-made service to check against a password against a list of username password pairs. I think that's out there. That's have I been pwned? There's an enterprise version of it. To check against a list of common passwords, Thomas, I think that requires a bit more work. I would go to let me dig into this. I got time to pull this off. Let me see if I can pull this off for you, Thomas. I'm answering questions coming in. Can you see my browser right now, by the way? Or
yes.
Okay, great. So browser. This is Daniel Miesler's sec list here, Thomas. When I go down to passwords, see, updated. He keeps them up to date. Last update 2 months ago. And I'd say common credentials here, and there's your list. But the thing is, these lists are just any possible password. So I would write some code that checks each of these passwords against your password policy and take the top 50 to 150,000 passwords that would typically fit your policy and add them to your block list, and that's what the standard is asking for. No easy turnkey service to pull this off. I just do the work yourself. It's not that big of a deal. And update that list on a regular, every like year or so, update your list. And that will handle what the standard is asking for here. I hope that answered your question. Rock on. I'm gonna say, yeah, so we got your question in there. Awesome. I'm gonna go to the interface and just to make sure I acknowledge the question, I'm gonna say answer live is done. There we go. How to implement rate limiting bot detection without torturing users with captchas. Any recommendations? You know, Maximilian Gola is asking this. I don't have a good answer to that. That's a bit out of my area. I know that there are, I don't even recommend it at the code level. It's usually network level, appliance level, service level, operational team level. It's rare where I'm trying to build this in my app itself. And it's something usually you want to buy as well. There's a whole like industry of companies that provide bot detection services in a variety of different ways. So that's why I almost don't like to talk about it. It's more the commercial space. But if you're doing real serious app development, big money, big customer base, it's really worth considering, especially if you have a weak authenticator, no multi-factor. It's nuts. But some people have good reasons for it, whatever. Let's move on. We're moving on. So, and again, last note, allow any printable character, even emoji, any printable Unicode character, because users have this on their keyboard. It's not a joke here. I'm dead serious, except anything but a control character. And now we're giving users the ability to make a good password policy. One of my writing partners is good old Belgium Dr. Derick. He's I like Philippe. This is Philippe Derick. He has like a PhD in web security and I know a lot of people with PhDs who barely lift a finger. This guy is he's like a deep, hardcore worker, takes this stuff seriously. Keep an eye on him. And Dr. Derick makes 3 suggestions. Include a password strength meter to inform users that they're doing the correct password. Make sure your password system's compatible with password managers so the paste function and big passwords work, and show the password while they're typing it in as an option for mobile devices. This is really common in the mobile world these days. Even in the non-mobile world, we see that often. An option to see the password. If you're asking the user to type in a larger password, to see it is sometimes helpful if they're not using a password manager. I'm going to jump ahead here. Why should this password not work in your system? It's got the word password in it, context, got a dictionary word in it, which is okay, but it's got the password word, which is contextual to the password field. It's also 10 characters. It's the 30,000th most common password out there. It's in the top 100,000 passwords in the world today. A lot of reasons why your authenticator should reject this password. You want to test? Go change your password. If they let you use this, that's a bad authenticator in my humble opinion. So that's my ideas on password policy. Go read NIST 800-63b. And not because of US standard, because it's got good ideas that we want to consider. I like to read European banking standards for authentication. They're forcing cryptographic certificate-based authentication and similar. So I look at European standards, like GDPR. We use that as a base for the California privacy law. So yeah, let's share from each other's wisdom around the world. Now let's talk about password storage. And I want to make it clear that this study, they asked 43 senior freelance developers to build a user reg system. 26 left the password as plain text from day one. That just shows how often developers get password storage wrong if they're building that feature themselves. So I want to talk about this. When does password storage matter? When does how you're storing passwords actually matter in your system? So number one, consider password storage is good. Password storage is going to matter when someone has stolen your data and is analyzing it offline. So this is an offline attack we're worried about. Attacker steals database, SQL injection, or other methods. Attacker analyzes database and discovers passwords from your users. So the thing is, attackers can use supercomputing ability from home. They can build Bitcoin mining rigs, GPUs. They can use cloud services to literally attempt trillions of hash attempts per second if you're just using a basic hash algorithm to protect a password. So this is the problem. Your database is stolen, and yeah, attackers use supercomputing capability to figure out what's going on. And this idea of password breaching happens all the time, you know, and look at Yahoo, they're at the top of the list now. They're Oath, they have like 7 billion accounts stolen. Anyways, I digress. This is a real epic problem. So we're worried about offline attacks. And here's a few quick pieces of guidance. Don't use hashing or encryption by itself for password storage. Use a password hashing algorithm that uses salting with a good password policy, and do special things like blocking common passwords. Now, if we look at some of the algorithms that people use for password storage, things like DES crypt, MD5, and MD5 crypt, it's almost free to crack them. We need to use bcrypt or scrypt with the good work factor. Remember, you can do like 1 trillion attempts per second on modest hardware in terms of the number of hashes per second hardware can do. And by using a work factor, a delay factor, bcrypt or scrypt, this will slow down how many attempts the attacker can make. What used to take maybe a couple hours to crack a password now might take months. And look at this list. This means 6-letter lowercase characters. This means 8 lowercase characters, lowercase letters only. This is 8 characters selected from a printable 7-bit ASCII characters. So this is like from the 95 printable 7-bit ASCII characters. That's this password policy. 10 characters we're talking about, again, 10 characters from the 95 printable 7-bit ASCII character range. This is 40 characters, 40 character string of English, and this is 80 characters of text, like some kind of random phrase. And the point is that even at large 40 character text passwords, using a simple algorithm is really crackable within a reasonable amount of time. So be careful here. I got a question coming in. What's your question? What about Argon 2? Hang on. Whoa, Thomas. Thomas is jumping ahead here. Don't worry, Thomas. You're right. First of all, Thomas, you are right. Argon 2i is one of the go-to algorithms today. So again, attackers have supercomputing power on their own. They can here this GPU rig will 4 of these put together in 2012, $5,000 will crack any standard Windows 7 password in 6 hours. This is a real problem. There's online hacking service as well that I can just pop a password in, a hash in, pop a MD5 hash into the service, and I get back to password done. So let's get this right. Thomas is like, Argon, and you're right. So 3 things, Thomas, not just Argon. Hash the salted password first. Then use Argon bcrypt or scrypt on the salted hash. And actually, I'm gonna change this. I'm gonna change my slide for you, Thomas, because you want accuracy. You're not gonna worry about salting anymore. I used to recommend that you as a developer do salting. Don't even bother with it anymore, because these algorithms I'm recommending, Argon, bcrypt, and scrypt, they do salting for you. You don't need to worry about that. I'm not even going to explain it. I want to get, in my brief, like 5 minutes, I want to get right to it here. So let's do this. Step 1, pre-hash the password. Here's why. If you allow a user to use a really large password, it's going to be a major performance problem. So if you take the password, bring it down to 512 bits, and then run it through the protection algorithm, regardless of the password size, you're going to get a measure of reasonable performance-based protection that still delays attackers when they're trying to brute force you locally. The other thing is bcrypt will truncate down to 72 bytes. So if you hash to 512 bits before you use the right protection algorithm, it'll solve that problem as well. This is a nice sanity check first step recommended by Dr. Devdatta, who published Dropbox's password storage, which is like the default standard these days, frankly. Number 2, use a right password hashing algorithm. Bcrypt has a time factor to slow down the operation. You'll take a couple second hit at login for each user, but when the attackers try to breach your, stolen your data trying to figure out passwords, it'll take them significantly longer to pull this off. Bcrypt has a time factor. Scrypt has a memory usage cost to limit parallelization, and Argon 2i can limit 1 thread at a time to operate on the algorithm. Does this really work? Oh yeah, it does. Absolutely it does. If you're using MD5, then my laptop can try 250 million attempts per second. If you're using SHA-1, same basic number. And if you're using bcrypt with my recommended work factor of 13, 390 with my laptop. So the point is, you're not going to stop the attacker from getting to your passwords. You're going to delay them enough for you to handle the incident by using these algorithms. Bcrypt is everywhere. It's in Java, it's in PHP, and native in PHP now is actually Argon 2i these days, is the new native in PHP. And there's a NuGet for Bcrypt in .NET. If we're worried about GPU rigs, Scrypt is best. If we're worried about custom hardware, FPGAs and ASICs, we want Scrypt with a 32 meg memory usage as well. And this could affect your performance, so please do load balancing rigorously before migrating to one of these performance sensitive systems. As a final sanity step, by all means, use key protection. If you have a good key storage mechanism in place, a good crypto mechanism, do a final round of encryption or an HMAC as your final step to leverage what key management you have in place. It's an optional step, which I see some people doing, and it's worth considering. If you're going to do a key round of some kind, do it in a sealed environment. User code should never touch a key. I like to isolate my key in a piece of hardware or service, send the password into the hardware, do the key, or send the whatever your phase of ciphertext is for this, send it into the hardware, decrypt or verify the HMAC, and then spit out the results without ever leaking the key to user code. This is the idea of keeping a key in a sealed service or a sealed piece of hardware. And I'm almost done here, folks. And by the way, Facebook published how they do password storage using all the techniques I mentioned. Go look this Alex Muffet. He's a character and a half. Go look up this conference and look at this presentation. It's a worthwhile discussion on the details of how to protect a password with some real rigorous methods. When you're storing a password, remember, hash it, bcrypt word factor 13, and a final encryption round, and put that ciphertext in your database. Then when someone tries to log in to verify it, hash the password they're submitting, decrypt what's in your database, and then use the bcrypt compare function against what's in the database and the actual password. If you get a verification, boom, you're ready to rock. That, and by the way, don't hard code passwords. Use a secrets management system, and be careful of things like backdoors with passwords like this. This is a backdoor to make you an admin. So the era of hard coding passwords is over. Make sure you're using some kind of secrets management. They're available in every major software and cloud stack today. I'm ready for any questions if you have them. It's my pleasure to speak on this topic to you today, and I'm glad that the Zoom hackers couldn't breach us this time. But it's fun. I'm happy to talk to you. If you have questions for me beyond this talk, I'm jim@manico.com. My job is I'm a professional educator. If you're looking to teach your developers on secure coding, keep me in mind. So Tom, is HSM a performance bottleneck? Yeah, maybe, Thomas. If an HSM is a performance bottleneck, just do a separate microservice. Do a separate microservice where you're able to at least stop the majority of app-level code from touching a key. And so a lot of people use a secrets management vault, and then they just take the key out of the vault and use it in the app, and that's insanity. That defeats the purpose of it, and that pattern's wrong. So some kind of key isolation is thoroughly important, in my opinion. So yeah, there you go. Do you recommend deploying 2FA when it's only SMS-based? You know what? MFA with SMS is better than nothing. If you combine a good password policy with SMS-based MFA, that's better than nothing, and I would start there. MFA is one of the worst, though. I'm sorry, MFA for SMS, one of the worst. But want to get crazy here, Max? Any kind of multi-factor that sends you a number is bad, because that's all vulnerable to phishing. The attacker builds a phishing site. Hey, give me your password, triggers the MFA, you enter the number in, and then phishers can use that to pop your account. So it's not just SMS, it's any number entry multi-factor. That's why you should be considering FIDO or cryptographic or signature-based authentication. So no one's just typing in a number. It's more push or crypto or FIDO based. I see no more questions. I'm off to another podcast in 10 minutes. It's my pleasure, everyone. Have a great day. Be good to each other. Stay healthy. check in with your friends, stay social, and be safe out there. Thank you for your time, everybody.